Yesterday, we talked about solving quadratics, but they are all basically of one type. They were missing the b value in the middle. We solved using the square root method over and over again. We looked at some different types of those. Today, we're going to look at all three parts being there. And so this is our generic form. And whenever we solve a quadratic, typically, and I know yesterday we didn't really set it equal to 0 because we were using the square root method, because we were missing the b value in the middle. But today we're going to see ones that have all three parts, so we're not going to be able to do the square root method. Okay, so I'm going to show you some other methods that we could do, and we're going to tie in some things that we've been doing a lot recently to help us solve in some cases. And by the end of the day, we're going to have 3 or 4 different ways that we can solve quadratics based on what type of quadratic I have and what's the best way to get them. So if I were to give you one like this, x squared plus 9x plus 20 equals 0. So what we're going to say is that we can solve by factoring. And we actually did this a little bit in chapter 6, the one where we did a lot of factoring. And we did a lot of factoring in that chapter, but then we also solved some equations. And so we've actually factored and solved a little bit like this already. And we can't do the square root method like we did yesterday because now we have the 9x added in here. And I can't just take the square root of both sides. If the 9x was not in there, that's when we use the square root method. Okay, so what we're going to do here is the good old product and sum method. Okay, we cannot. There is no GCF. Okay, we're just looking at 9x squared plus 9x plus 20. There's no GCF. So now we're trying to apply some of our factoring methods, right? And so we're still back in factoring here. What can I do? What can I multiply to get 20 and also add to get 9? 5 and 4, okay? And so what we have done a lot of is we'll go ahead and factor it. And then we set both of those factors equal to 0, which, like I said, we've already done this in a lot of, when we were doing chapter 6. It's been a little bit ago. And then I subtract 5, I subtract 4, and those would be our 2 answers. And we talked about this a little bit yesterday. The nice thing about a lot of things that we're going to be doing in this chapter is we can check our answers. And in order to check our answers here, both of these numbers could be plugged back in for x, and we could determine if it really does equal 0. So like for instance, negative 5. Negative 5 squared would be positive 25. 9 times negative 5 would be negative 45. So 25 minus 45 would be negative 20. Negative 20 plus 20 gives me 0. Works. And same thing, if I plugged in negative 4, it should also work. And I'm not going to go through and show you every single time that every single one of these should work and that it does work. But just know that you can check it. If you're ever not sure of your answer, always plug it back in and see if it works, especially when you have an equation. Okay, this one we can't do the square root method because we have an a value and a b value. Okay, this is kind of like what we did yesterday, but this one has an x attached to it. So when I look at this one, what we have to do is determine how we're going to factor. Okay, and we go back to our factoring tree again. All the different methods. What's the very first method we always look for? GCF, okay? The last one did not have a GCF, this one does. And so in this case, we can take an x out. Okay, and then this one is very similar, except X is one of my factors. X minus 9 is a factor. Both of those get set equal to 0. And so over here, this is all I can do. There's no adding or subtracting or anything that needs to be done. We take the GCF that we took out, set it equal to 0, and that is one of my solutions. Here we're going to add 9 to both sides. We get x equals 9. Okay, so we could do just the GCF and then set it equal to 0 and get our solutions. Bless you. Okay, if I give you one like this, the first thing we always want to do, and a lot of these are already going to have this done, but we always want to set the equation equal to 0. Okay, have to set it equal to 0. Okay, extremely important step. We aren't just going to like take an x out on the left-hand side. Before we do anything, before we do any factoring or anything else, we always want this equation to be set equal to 0. Okay, and so all I have to do to get it in that form is subtract 6, and it gives me 4x squared plus 5x minus 6 equals 0. And now it's a trinomial. Now it's in the standard form of a quadratic. And we'll keep talking about this because we're going to talk about more here in just a second. This is my A value, my B value, and my C value, so it has all 3 parts. Do we have a GCF here? Nope, nothing we can take out, okay? And then it's a trinomial. It's not a perfect square trinomial. Can we do product and sum here? How do we know if we can do product and sum or not? Whatever number's in front of x squared, right? If there's nothing in front of x squared, then that's when I do product and sum. If I have a number in front of x squared, what am I going to have to do here? Good old slide and divide, right? Our favorite. So my product here would be a negative 24. My sum would be 5. So I got to find 2 numbers that multiply to get a negative 24 and add to get 5. What 2 numbers make those 2 things work? There we go. Yep, positive 8, negative 3. Okay, those 2 add together to get 5. And I like to use the chart. You don't necessarily have to use the chart, but you're just trying to get something that works. Like there's a lot of things that go into 24. 12 and 2, 6 and 4, 8 and 3, 1 and 24. You just got to keep doing until you find something that works. Now, when we do slide and divide, we put both of those numbers in our parenthesis, but we got to put a number on bottom. And what number do we put on bottom? The number in front, right? 4. So we're going to put 4 underneath both of those. And then once again, this is why we call it slide and divide. If it divides, we divide it. 8 divided by 4 makes 2. So we just simplify it. Okay? If it does not divide, then we slide it. So the 4 slides in front. Okay, and here's the part that's kind of important. These are the 2 factors that would make this. If I were to FOIL these 2 things together, it would get me back to here. Okay? And we're not going to do that, obviously, because we're trying to factor it. We're trying to get to here. But once I get to the factor part, what do you think we're going to do? What's our whole goal for today? Find the value of x, right? And so if these are my 2 factors, I'm going to set both of these factors equal to 0. Okay, these are my 2 factors. Set the factors equal to 0, like we've done on the last couple. We're going to subtract 2. And then add 3. Divide by 4. Those would be our 2 answers. Okay. And we will get some fractions from time to time as our answer. So really any factoring is in play. I mean, I didn't give you any that are DOPs, but we could see DOPs. Probably won't see perfect square trinomials. We probably won't see grouping either. Okay, so product and sum, slide and divide, GCF are all things we could see, and DOPs could be thrown in there as well. Any of those things could be fair game as far as factoring to solve. To, like, let's say this one here. Could I do the quadratic formula on it? Yeah, right? I just identify A, B, and C, and I would still get these 2 answers as my solution, okay? I would still get those 2. It just kind of depends on what you have as far as what kind of solution you're going to get. Let's do another one where we get a little bit different answer. This one's already set equal to 0. Okay, and the reason I always say try to factor it first, because I think it's a little bit easier process. I mean, we can do the quadratic formula on every single one of these if we want to. But doing the quadratic formula is kind of a lengthy process, right? Number 1, we got to remember the formula. Number 2, we got to plug everything in. And then we got to simplify everything. It's kind of a lengthy process to go through. So this does not factor. There's no GCF. We would try to do slide and divide. My product would be 15. My sum would be 10. Doesn't work, okay? So you could try to go through the factoring, but when I get to that point and I can't do any other method, then my last thing on the list would be the quadratic formula, at least in my opinion, okay? You could jump right to the quadratic formula if you love doing the quadratic formula, but that would not be my go-to. All right, so let's plug this in to the formula. X equals the opposite of 10, plus or minus. 10 squared would be 100, minus 4 times 3 times 5. All over 2x. Oh, I should do A, shouldn't I? Yep. Why did I write A? I don't know why I wrote A. 2 times 3. Okay, and then we're going to simplify it as we go. 4 times 3 is 12. 12 times 5 is 60. 100 minus 60 would be 40. All over 6. Okay, I kind of like to take 40 is not a perfect square. This time it's not negative. So this would be 4 times 10. And once again, I use 4 because it's a perfect square. There's a lot of things that go into 40, but like 8 and 5 don't really help me because neither one are a perfect square. So I use 4 times 10. And once again, if you want to use that tree diagram like we talked about yesterday, then that's perfectly fine too, if that makes more sense to you. Okay, but here, the square root of 4 becomes 2. So this is x equals negative 10 plus or minus 2 radical 10 all over 6. Okay, and there's really 2 ways that they're going to ask us to express our answer. Okay, one way is to write our answer in simplest radical form. So in this case, bless you, we're going to say negative 10 plus or minus, oops, sorry, not negative 10. We're going to take a 2 out of all 3 of these. Okay, kind of like we did on the last one. All 3 of these have a 2 in common. So this would really become negative 5 plus or minus radical 10 all over 3. This is what we call our exact answer. If they ever ask for an exact answer or a radical answer, that's how we would leave it. If we want the decimal answer, then we would put this into our calculator. Okay, and there's going to be two solutions. On most of the problems that we do here, there's going to be two solutions. Okay, and to get those two solutions, we're going to put this into our calculator. So let's get your calculators out and let's try putting this in to your calculator and see if we can get the decimals. So the way that we're going to type it in is -5 plus the square root of 10, and then divide by 3. If I round to the nearest hundredth, the first one should look like that. Okay, the second time through, we're going to do -5 minus the square root of 10 and divide by 3. And these would be our decimal answers. Okay. So it kind of just depends on how they ask us to express our answer. Anybody need help putting that into their calculator? You guys able to get those decimals? Okay. So -5 plus square root of 10. Okay, and then I would get out of that radical. Okay, so here's what you've got to make sure. I would go back to here. And what I would do is just do this first. If you want to do it all at once, you have to put that in parentheses. But I would just do the top first. And then divide by 3. All right, everybody able to get these decimals okay? Okay, if it ever asks to write your answer as a decimal, that's what we're looking at. All right, last thing that we're going to talk about today is the discriminant. When we solve the discriminant tells us how many and what type of solution we have. We are not actually solving it when we have a discriminant problem. The discriminant just tells us how many solutions we have and what type of solution it's going to be. Okay? And we're going to talk about this more next week, but when we graph a quadratic, and I know you guys have seen this before, there are essentially 3 different types of answers. The one that we see the most would be like this. And we say, how many times does it cross the x-axis? Well, it crosses it 2 times. All quadratics are going to make that U shape, that parabola shape. Okay? We also could have a parabola that comes down and hits the x-axis and then pops back up. So this one would have 2 real solutions. This one has 1 real solution. And then this parabola never crosses the x-axis. And so we would say that this one has 2 imaginary solutions. Okay? So when we're looking at a graph, we could easily determine what it's going to look like. And we're going to graph next week and do some stuff with the graphs of these. But that kind of brings back some things that we've talked about before. All right, so the discriminant. The discriminant is b squared minus 4ac. We've seen it before, right? It is not a new formula. It is the part of the quadratic formula that's underneath the radical. And so b squared minus 4ac is what we call the discriminant. And what it does is it tells us how many solutions there's going to be. It could be greater than 0. It could be equal to 0. Or it could be less than 0. Okay, so this means it would be positive. Equal 0 is pretty straightforward. And if it's less than 0 means it's a negative number. Okay? If it is greater than 0, we will have two real solutions. It'll cross the x-axis twice, if you go back to the graphs that we talked about. If it is equal to 0, it'll have one real solution, and if it's less than 0, it will have two imaginary solutions. Those are our three possibilities, okay? All based on the discriminant. So let's look at an example. 3x squared plus 10x minus 8. Okay, same thing here. Make sure that it's set equal to 0 so we can identify A, B, and C. If it's not set equal to 0, the same thing holds true here. We still want to set it equal to 0. Okay, but we are not solving it. Okay, whenever you have a discriminant problem, you don't have to say what the solution is or solve it. You just have to say what type and how many we're going to have. And these are your three options right here. Okay, so this is A, B, and C. So we are only going to plug it into this part right here. We're not doing the entire formula, just b squared minus 4ac. So 10 squared would be 100 minus 4 times 3 times negative 8. Okay, this number right here is probably the thing that throws most people off more than anything else, is the signs, positives and negatives, okay? And you can treat that a lot of different ways. How you treat it really doesn't matter to me. Same thing here. Some people think of this as a negative force. Some people think of it as a minus sign, okay? And they say, well, what's the difference? Well, not really anything. I like to do all three of those numbers together, though. However you want to do it, doesn't really matter to me, but you just got to watch your signs. 4 times 3 is 12. 12 times negative 8. What would 12 times negative 8 be? Negative 96. Okay, and then notice we have two negatives there, right? So if I took 100 minus a negative 96, what would that end up making? 196. Okay, we'd have to add those two together. Okay, and the only question we're asking ourselves is this number positive, 0, or negative? Well, obviously 196 is positive, so we would say that there are two real solutions. Okay, and I'm not going to necessarily give you an example of all three of those. Okay, it all just matters of what number we get right here. If this was 0, it would be one real. If this was any negative number, it would be two imaginary. And that's how you're going to answer that question. Is 2 real, 2 imaginary, or 1 real? Okay, and those are my only three possibilities. All right. Here's what I will tell you on your problem today or problems. You can use whatever method you want on some of these. Like if it says choose your method, but you probably need to practice some of each. So if you can factor it, factor it. If you can do quadratic formula a couple of times. I know we can do quadratic formula on all of these, but like I said, I wouldn't probably do that because some of these are going to be, you're going to be able to solve it a whole lot easier than that. So just kind of pay attention to the directions on like methods that they want us to do, or if you're doing ones with the discriminant, you don't have to solve it, so those should be a little bit easier than some. Okay. Another one that is very similar to one we saw a little bit ago And what we said was our first step's got to be what? Set it equal to 0. If it's not already set equal to 0, we always want to set it equal to 0. And in most cases, that just means moving one number over to the other side. And so we're going to add 3 to both sides. And we get to here. Hey, now, as we look at this one, okay, as we go kind of through the process, we can't do the square root method that we did yesterday. We can't do product and sum here. And here's why we can't. Well, first of all, we can't do GCF. I should start with that one. There's nothing that we can take out of all 3. Okay, product and sum. We can't do product and sum because we have a number in front of the x squared, right? So product and sum is out. If I tried to do slide and divide like the last one we did, my product would be 9. My sum would be -4. So what are some things that go into 9? 3 and 3. Will 3 and 3 ever add up to be 4? No. Okay. The other thing that goes into 9, we could do 1 and 9. Is there any way we can put 1 and 9 together to make 4? No. Okay. So then what that tells me is that this does not factor. That doesn't mean we can't solve it, because we can solve it, but we can't factor it to solve it. So we got to have something else that we can do. Okay. So we have a quadratic equation, and we want to be able to solve that quadratic equation. Wonder what we could do. Anybody remember from previous years what we could do to solve this equation? Hey, there it is, quadratic formula. You could probably rip it off too, right, Jacob? Just quadratic formula. Remember it? No? All right, let's see if we can mix this all together here. Okay. X equals, okay, so this is the good old quadratic formula. It's been a while. Okay, what's the first part? On top. X equals negative b, opposite of b, plus or minus there you go. You have it, huh? There it is.
Don't ask how I remember that. I don't know.
Do you have a song that you remember? No?
I don't know why I remember it.
Hey,
I just forgot.
good thing is you knew it. All right. You guys heard the Pop Goes the Weasel song that goes with this one? No? I can. Don't laugh at my singing, though.
It'll never be out of your head. I'm pretty sure I have heard it.
You probably have heard it, yeah. There's a couple of different songs, but mine's always Pop Goes the Weasel. Okay? Ready? Quadratic formula. X equals opposite b plus or minus square root b squared minus 4ac all over 2a. Not bad for a Friday, huh? You what? So a couple years ago, a kid videoed me doing that and like shared it like on social media, and so it was like I didn't know it was going on until my daughter told me. So you guys kind of remember that? I guess there's worse things you can get videoed doing probably, huh? Than getting shared. All right, so going back up here. We have an A, a B, and a C value, right? Whenever we have a quadratic equation, we have an A, a B, and a C value. We're going to take those 3 values from this equation, and we're going to plug it into our formula. I know. It was doing that like a month ago, and then it stopped.
And now it's
I know.
Can we just kidding.
It was kind of like it was right around Halloween, you know, so it was kind of like the strobe light effect maybe. But now it's just kind of a pain in the butt. And I said something about it when it was happening way back when, but nobody ever did anything, and now it's back to maybe even worse than it was. All right, so here's our A, B, and C value. The opposite of B. B is -4. I always read this as the opposite of B. A lot of people think of it as negative B, but this is not always guaranteed to be a negative number here because B is already negative. So when I say what is the opposite of -4, this would really be a +4. Okay? Now, what I always do here is when I do B squared, this number is always guaranteed to be positive because whenever I square something, I always get a positive number, okay? So I don't really like to write -4 squared in here because a lot of people forget to put parentheses around it and then they get a negative number right here. This number here should never be negative because we're squaring it. So if I square a -4, I get 16, okay? So I'm just going to go ahead and square it. I don't like to write out -4 squared because I think it causes issues. And then 4 is always 4. It's part of the formula. Times 3, which is A, times 3, which is C, just happens on this one, they happen to be the same number, all over 2A, which is 2 times 3. Okay, so now we got to simplify this. When we simplify this, we got to do order of operations. 4 times 3, 12. 12 times 3 is 36. So this is 16 minus 36 all over 6. (16 minus 36 would be -20. Okay, now this is going to kind of bring in some things that we talked about yesterday. Is 20 a perfect square? No. Okay, so when I break down the square root of -20, I'm going to do -1. And however you want to do this is kind of up to you. That's what we talked about yesterday. You can do -1 times 4 times 5, and the reason I choose 4 is because it's a perfect square. I wouldn't want to do like 2 and 10 necessarily. I want to find something that's a perfect square if I can. And then I can take out the square root of -1, which becomes I. And we can take out the square root of 4, which becomes 2. So this would all become 4 plus or minus 2I radical 5 all over 6. So we can still get imaginary solutions, right? And that's what we've got here. You're not always going to get an imaginary solution, obviously, if you do the quadratic formula. And we'll talk about that here in just a second. But the one thing we can do here, all of these, and we talked about a lot about simplifying fractions. If I can take something out of all 3 of these, I'm going to take it out, okay? All of these have a 2 in common. And so this would be 2 plus or minus I radical 5 all over 3. And that would be my answer. Okay, so we will get I's sometimes. Sometimes we'll get decimals for our answer when we do the quadratic formula. It just kind of depends on what type of problem you have and what you got. Okay, if I were to go back